Cranes, seaports, for that matter, tunnels and bridges, critical infrastructure. If they were to collapse, literally come down, it would cause massive devastation. So what if you could predict the future? Calculate those chances of failure. This next innovation is all about avoiding a catastrophe.
Engineering structures, we build them to be stable, but quite often you get variables that happen that cause them for some reason to become unstable, and what you want to do is be able to prevent those things from failing before they cause damage.
Lee, what are we doing here at the Brisbane Port Authority?
Pete, basically we're making land over water.
Right.
We've created a large rock wall around this area and we're filling it with all the sand from dredging operations in the bay.
Yep.
And we're using the Kurloos to measure precisely what the rate of settlement and stability of that rock wall is. Pete, come up and have a look at one in the wild.
Okay.
What we've got here is satellite positioning and a sensor system all embedded in one compact, easy to install instrument.
What is it actually doing at the moment?
This system here is similar to that GPS that you use in the phone, similar components. It's observing the satellites and then triangulating that information to get a very accurate position on the Earth.
It's a neat looking little innovation.
Before we invented Kurloo, Pete, we used to haul around truck batteries and large solar panels to do exactly what we do with this Kurloo. I'll tell you, there's a story behind it. When I walked in the door, I knew all about the technology, but what I didn't know about was how I'm putting it into a precise little package that could be manufactured at scale.
You arrived with an early version of the Kurloo. Shall I say it's just a challenging piece of geometry.
Correct.
Right? And so you guys were presented with this and you thought, hey, we can do better than that.
Yeah, absolutely. So when Lee comes in with something like this, we can take a lot of learnings from what he's brought to us.
Yep.
So then going through the design process, this is what we came up with, which is the Kurloo. The tapered cone really was driven by the fact that we need the sun to power the solar panel. We wanted water to drain out to self-clean as well, and we really wanted to prevent birds from sitting on it.
The things that come out of seagulls aren't particularly good for solar panels.
Got it.
So Pete, I wasn't going to show you this, but here's some of the key stuff that we packed inside a Kurloo. Inside here, what we managed to do is bundle all that complexity into this tiny little package. Integrated solar panel, battery systems, electrical design, and the key component is the GNSS antenna. This receives signals from 20,000 kilometres above the Earth and gives you millimetre precision.
That's insane. I mean, how is that possible?
It's built on years and years of development from lots and lots of people to get you to the point where you're able to get that level of precision in a compact device like this.
Actually, what's driven a lot of this innovation is around drones, autonomous vehicles now. Positioning is becoming commonplace, and we've just managed to leverage that to make a very unique unit that is absolutely a dream to use for consulting engineers and people that want to detect precise movement of structures.
So Toddy here is monitoring exactly how much movement is happening at the Port Authority. How's it looking?
It's doing exactly as they expect it to do, which is great.
Yeah.
But without visual physical signs on the ground,
Yeah.
we can help them to see that before cracks start to develop, I guess you could say.
Okay. And this can be monitored from anywhere in the world.
That's right. All you need is an internet connection and a web browser.
A scenario, the Leaning Tower of Pisa. If there was a Kurloo on top of that and it moved 5 centimetres,
Yeah.
an alert would then be sent to an Italian engineer going, you better get over there.
Yeah, absolutely. Totally. That's exactly what it's designed for.
Here at IntelliDesign, we test our products hard. We want to know that they're going to keep working out in the field.
Oh, looks pretty cold. Can you see how frosty that is? Oh, it's freezing. And it's still working. Now, how hot would you test it for?
70 to 80 degrees C, out in the hot sun, the Pilbara.
Okay, so from frosty to hot, and what about the water test?
I wouldn't recommend that one.
Drop it straight in.
It's not something we've done.
What could possibly go wrong? Let's give it a go, right? I tell you what, that proves it. From the top of a snowy mountain to the middle of the desert to a heaving thunderstorm, the Kurloo is still cranking. As they say, the best way to manage a crisis is not having a crisis to manage. And that's what Kurloo aims to do, measuring movement so action can be taken before the walls come tumbling down.